Okay, welcome to the webinar. So there are now students. We have facilitators from First EduSpec Inc. So they are our teachers as well in the Ust-Angelicum College. We have Miss Laika. We also have Sir Claude Amores. Okay, can you hear me clearly? Can you comment yes if you can hear me clearly? Okay, so let's start. So again, welcome to the webinar hosted by First EduSpec Inc. for the Ust-Angelicum College Senior High School learners. So my name is Vincent Luis Cayabyab and I will be your facilitator for this hour. Currently, I am the program manager of First EduSpec Inc. I am also a certified CMA Level 3 Master Trainer for Vexcode. I also teach robotics and I'm also a special education teacher. Okay. So I apologize if you're hearing some background noise like the rain and my muffled voice. So I need to use some compression with this one so that it could lessen the background noise. Okay, our agenda for today. So you learners will be able to learn how to navigate the Vexcode VR, learn how to use the playground inside the Vexcode VR, learn where to get information about each block. So these are the command blocks. So later you'll see where is the help or some of the tutorials. So overview of this webinar. So this will last for 45 minutes for the presentation and we will be having 15 minutes for the Q&A at the end of the presentation. So questions can be submitted via comment section of this stream. So what is Vexcode VR? So Vexcode VR is a virtual platform which you can use to program your VexIQ robot. It is web-based, meaning you don't need to install anything. You just need to access the website for Vexcode VR through any device. So again, since it is web-based, you can access it through any device. So if you have your laptops with you, your computers, tablets, and mobile phones. However, when you're going to use your personal phone, be reminded that the space you have for programming may be limited. So it is due to the screen size. So it is recommended to access it on a device with much larger screen size, such as tablets. So why Vexcode VR? So it helps develop coding solutions with a robot, provides a relevant context for engaging students in computer science, so such as you. Robot with sensors and physics integrate CS into STEM. So we have here our STEM students. Virtual playgrounds help to contextualize STEM learning and authentic student inquiry. So in our Robot C, we have the virtual world or the RVW. Here, we will be having the virtual playgrounds. So later, you'll know what are the playgrounds. So activities provided have a structured and approachable STEM learning experience. Vexcode VR knowledge and principles translate directly to VexIQ and other Vex platforms. Okay, So Vexcode VR is very easy for the students such as you to learn because the programming quirks and features are just similar with the Vex IQ Robot C. So it's just that there are added features. Next, we have the Vexcode VR features. What are those? Again, it is web-based, no software installation needed. We will be having virtual robots, so it's pre-built, uses drivetrains and sensors. And we also have pen, so it has a pen feature. And we have the virtual playground, so there will be different virtual 3D playgrounds. Programming language, so it is similar to Vex IQ Robot C. It is C, okay? So challenges and activities, there are approximately 45, I think, activities that you can use to help you master the Vexcode VR. Then we will also have the live dashboard. It helps you visualize data on the playground's dashboard. So what are the supported browsers we have for Windows? So most of you, I think, are using the Windows 10, Windows 7, Windows 8, or 8.1. So for Windows, you can use the Microsoft Edge, Google Chrome, Mozilla Firefox. For Mac OS, you can use the Apple Safari, Google Chrome, Mozilla Firefox. For iOS, for the tablets, we have the Apple Safari. For Android, you can use the Google Chrome, and same with the Chrome OS. Okay, so for this one, students, you should at least have a Windows 7 computer. Okay, at least Windows 7 for the Windows supported browsers. Parts of the robot. So here at the middle on the left side, we have the pen, we have the electromagnet, we have the down eye, we have the 50mm diameter wheels. At the top view, we have there the built-in gyro plus location sensing. Front eye, this one for distance plus distance sensor. We have the left and right bumper as well at the front. So this is somewhat similar to our standard drive base with the Vex IQ robot. So getting started. So I'm going to close this one and I'm going to open my browser. Okay, so here I have the Vexcode VR. In order for you to access the Vexcode VR, you just need to type in at the address bar vr.vex.com. Again, that is vr.vex.com. Okay, next. Oh, just a quick review. Since Vexcode VR is web-based, you can access it at to any device. However, again, it is recommended not to use any smaller device than a tablet. Okay, so let's start. I'm going to open my magnifier. So there we have on the upper left, we have the VR logo. We have also the globe icon. For this one, you can set your language. Next, we have the file. For this one, if you click file under the file menu, you will see the new blocks project for this one. So whenever you want to create a new file, this is where you need to be. So just a reminder, whenever you create a new file, please make sure that you have already saved your current file because your current file will be discarded if you don't. So just like this one. So if I drag this one there, And then if I try to click New Blocks Project, it will give you a prompt. Your project was never saved. Save now. Okay. So since this is just a test project, I'm going to discard this one. Next, we have the load from your device. There. So basically, it will just give you an option to load a previously saved file. So when you click Open Examples here, next, we have the Open Examples. If you click this one, a list of examples will be shown to get you started. It has a filter system, so I'm going to click this one there. So it has a filter system that sorts the 40 plus examples based on the contents of the program. So there we have the all, we have also the drivetrain, the looks, control, sensing, operators, and variables. Okay, so I'm going to click back. Still under the file menu, you have there save to your device. So whenever you click save to your device, it will automatically download and save your file in your downloads folder. So if you're using a web browser for Windows or for Mac OS, it will save the file to your browser's download folder. Okay. And then we have the about. Next, we have the tutorials. This one. Currently, we have 3 tutorials. Let's see. Oh, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we are currently having 12 tutorials for this one. If you want to learn more about turning, getting started, my blocks, using loops, for using help, or examples and templates, you can watch the videos here. A very cool feature with Vexcode VR is that whenever you want to watch a tutorial, you can still continue to work with your program. So it will open up a new window that will overlay to your workspace. So for example, I'm going to click turning. So this is turning. If I click it, there. So it will open up a new window that is overlaid on your workspace. So for example, I play this one. So while watching the video, you can program. There. Okay. Let's close this one. Again, for the tutorials, you can use this one while working with your activities, or if you want to learn more about these topics. Next, we have the activities. So if you click activities, it will direct you to a different tab that contains free activities for the Vexcode VR. So if I click this one, so it will direct me to education.vex.com/VR. So here we have some activities. There. So again, it will direct you to a new tab. So I'm going to close this one. Next, we have here at the middle. So we have the Vexcode VR project here. So in Vexcode VR, all projects begin with a default name of Vexcode project. If you want to give a name or a different name to your project, you just need to select the project name from the toolbar. So here we have the blue toolbar. Going to click this one, and then it will prompt you to give you a to give this project a new name. So for example, here I'm going to type getting started, then click rename. Okay. Next, we have the playground. So we are now at the upper right corner. Here we have the playground. In Vexcode VR, you can program a VR robot to complete your activities in different environments called playground. So this is similar to our robot virtual world with the robot C, but here we have different playgrounds or virtual worlds. So by default, playground will load a grid map. This one. When you click the grid map, a drop-down menu will show up. Let's click this one. So there we have grid map, number grid map, art canvas, disk maze, and so on. Okay. So each playground ranges from -1000 millimeter to 1000 millimeter for the X and Y positions. So the starting position of the VR robot depends on the playground selected. So here, for example, we have the grid map. The robot starts here. If I choose wall maze, the robot starts here. Okay. So here in the playground, on the left side, we have here the expand. So if we click expand, it will give you a bigger view of your playground. Then it will be replaced with shrink. So liliit siya. There. Then we have the hide. So it basically hides the playground, but the toolbar is still there and is movable. For example, this one. I'm going to click this one. So you can work with your project while having the playground still in the overlay. And then you can click show or hide. Okay. Next, we have the activities. So this one is similar to what we have done a while ago. If you click this one, it will route you to a different tab, and then it will list down all the present activities or the latest activities, and then close. So with close, basically it will just close everything for the playground. So it is not hidden, it will close. So I'm going to click this one. So under the brown toolbar, you will see the live dashboard. So we have here the heading, the rotation, the front eye, down eye, location. We also have the location angle, bumper, and the distance. So this basically gives you a live update of the heading and so on. On the lower right side of the playground, so just like in our RVW, we have the cameras. So here we have this one. This is the top view. And then for this one, we will be having the chase view. So chase view basically follows the robot wherever it goes on the playground. And then here at the top of the camera views, we have this one. If you click this one, it will hide the live dashboard, or if you click it again, it will show up. And then on the left side, we have the play and the reset button. So I'm going to close this one. Let's continue here. So we have start, step, and stop. So this helps you control your robot. Next is we have the share. So this is a very cool feature again of Vexcode VR, as it lets you have an image of your program saved as PDF when you click it. So for example, this one, I'm going to click this one. So if you click share, it will automatically download your program. So here, we named our program Getting Started. It will download gettingstarted.pdf. So I'm going to click this one. So there. So that is your program in PDF form. So I'm going to close this one. Then we have lastly the feedback. Below that one, we also have the help. So in order to use it, you need to select a command block. So if I click this one, help, and then if I click drive, so it will show everything that is all about drive. So for example, turn, there. So now all the information about that block is up. So whichever block that you want to learn more, you can just select another block. So this is a very helpful, especially if you're a beginner. I'm going to close this one. Then delete. Next, we have here the when started. This one at the middle. So basically, it's just where you will branch your command blocks in order for it to run. So here in Vexcode VR, everything is drag and drop. So here on the left side, we have the command blocks. So if I click drive, I'm going to just drag it and place it under when started. Okay. Disabling a command block. So one of the features of Vexcode VR is to disable a command block without removing it. So just like deleting, but it's still there. Okay. So the robot will not read that command, but the program or the command block is still there. So what you need to do is just right click this one, duplicate, disable, and delete block. So here you can click disable block. There, so it will be grayed out. Going to enable this one. You can also duplicate this one or delete. There. I'm going to drag this one again. So there are ways on how to delete a command block. So first, just like what we did a while ago, right click this one, the block, then delete block. Or you can click the command block and drag it back on the left side. Another one is by clicking or by pressing the delete on your keyboard. There. So again, on the left side of the interface, we have the command blocks. So it is again in a filter system. So every command block is filtered based on its use. So for the different filters or categories, we have the drivetrain, we have the magnet, looks, control, sensing, operators, variables, my blocks, and comments. So for under the drivetrain, it contains the basic commands of the VR robot, like the drive forward for blank, turn right, or for turn for 90 degrees, turn to heading, turn to rotation, stop driving, set drive velocity, and so on. So here, the drive for block, This one. Drive forward block is somewhat similar to the forward command of robot C. It lets the robot drive forward or backward for a specific distance, and you can select millimeter or inches. So if I click forward, we have there forward or reverse or the backward. And then for the second parameter, you can input any value. And then here for our unit type, we have the millimeter and the inches. Okay. Here in our drive block, this is somewhat similar to set multiple motors because it will let the robot continuously move forward or backward without any condition. For example, here in our drive forward 4 block, we have 200 millimeters. Here in the drive block, it will just continuously move forward. Next, we have the turn right, same with drive. It will continuously turn. Then we have the turn right for degrees. And then you can select 90. Let's try this one. So I'm going to click playground. And then I'm going to select grid map. Expand. So for this one, I'm going to use the chase view. And then click the play button. So there. So the robot turns to the right for 90 degrees. As you can see also here, the rotation is 90 and the location angle is 90. So the live dashboard again will give you information about the sensors of the robot. We also have here the turn to heading. Turn to heading can be used to turn the drivetrain to any given clockwise heading. So it accepts a range from 0 to 360 degrees. So it also accepts decimals, integers, or any numeric block. And then we have, if I scroll it down, we have the stop driving. So stop driving will make the drivetrain come to a complete stop. So it is very useful when you are using the drive block. So here I'm going to drag drive forward, and then I'm going to use a control. So for example, this one, and then I'm going to use the stop driving. There. Going to click the playground. And when you click play, there. So basically what the robot did was it drive forward for 1 second, and then the robot will come to a complete stop. Okay. Next, we have the set drive velocity. So for this one, this lets you change the speed of the drivetrain. So it accepts 0 to 100%. So just like in Robot C, the default velocity of the robot is 50%. You can change your robot speed with this one. So for example, I'm going to put it there. And then I'm going to set the speed of the robot from 50 to 10. And then playground. Chase view. Click play. There. So the robot moved forward with a speed of 10%. Again, if you want to save this one not in a Vexcode VR file format, you can click the share button. So I'm going to click share, then getting started. There. So that is your program. So again, just a reminder, Vexcode VR is recommended for use in a large screen to fully enjoy all the features. Next, we have the magnet here. So for the magnet, this basically sets the VR robot's magnet to different modes. I'm going to delete this one, and I'm going to use this block under the magnet. So we have the energize. So if I click this one, it says magnet, then this one, boost or drop. So boost attracts an object to the magnet, while drop releases any object the magnet is holding. So VR robot has an electromagnet to pick up and put down discs that contain metal cores. So the electromagnet is located at the front of the robot, pointing down towards the playground currently in use. So this one, you can use this one under the disk transport. This one. So if you can see, there are discs there. So the robot can go there, and then it will pick up the discs using the magnet. So let's try this one. Okay, so let's have drive forward for 700, then turn to the left for 90 degrees, and then we're going to use the energize. So I'm going to boost this one. So basically it will just attract the disc. It will lift the disc. Then drive again forward for 300 millimeters. Then let's have a weight control command. Let's have it for 2 seconds. And then use a magnet again. So instead of boosting, we're going to drop it. Okay, so this is our program. Now let's click the playground. So this is our disk transport. I'm going to use the chase view and then click play. There. So I'm going to play that again. There. So basically the robot picked up the disc and then it dropped it. Okay. So I'm going to close this one. So students, do you have any questions? You can just write it down on the comment section and we will address that one later. Next, we have the looks. So for the looks, this is for the pen. So we have 2 command blocks. So we have the move robot pen, which basically let you to put up or put down the pen. So I'm going to delete this one, and then I'm going to click move robot pen. So here, move robot pen, we have down and up. So the default location of the pen is facing upwards. So if you want to use the pen, you need to use the move robot pen command block and then choose down. Then you can also set different colors. So we have here the black, red, green, and we also have blue. So let's try a program here. So I'm going to put drive forward. So let's have 700. Then have it there set to black. And then I'm going to change the color from black to red. And then let's turn to the right for 90 degrees. And then move forward again. So let's try this one. Playground. I'm going to use the grid map. There. And then for the chase view. So this is our pen. This one. Currently set to black color. So we play this one. There. It will change to red. Again. Let's have that one again. This is our robot. Click play. There. So I'm going to show you some example of this one. Wait a moment. Okay, so here I've opened up a what they call this one, a program that was made by my student. Let's play this one. There. So basically, what the robot is doing is that it will draw a flag. There. So basically, my student drew a flag with letters KKK. Okay. Next, let's have control. I'm going to load a new program. So under control, there's one on the left side. So this section lets the program make conditions for the robot. So the VR robot then uses its sensors to detect if a condition is true or false, or just loops the command blocks. So control blocks or conditional blocks utilizes circular and hexagonal spaces. So these blocks are very flexible. You can use it with other circular and hexagonal spaces. So I'm going to what we call this one, drag some of the control blocks. So for example, here we have the repeat. It utilizes a circular block. There we have the number 10, and then we have for the if else, we have the hexagonal block. So again, these blocks are very flexible. You can use it with other circular and hexagonal spaces, but make sure that your code contains a valid argument. Let's drag it in another one. We have here the if else. So an if else conditional block again allows the VR robot to choose between two sections of code. If the condition is true, then the if section will run. But if the condition is false, the else section will run. Exactly one section of code in an if else conditional block will run, or will always run, as it only makes a one-time decision. So again, this is a general topic in our VexIQ Robot C curriculum. Again, for the controls, you can utilize a circular space or a hexagonal space. Okay, next we have the sensing. Sensing is divided into two different sections. We have the brain sensing, we have the drivetrain sensing, we have the bumper sensing, we also have the distance sensing, eye sensing, and the location sensing. Brain sensing uses the timer of the brain. The drivetrain sensing, for this one here, I'm going to zoom it, this one. For the drivetrain sensing, this one can be used with controls that utilizes hexagonal spaces. Oops, sorry. And also the circular spaces for this one. We also have the bumper sensing. The robot has two bumper switches. So we have on the both sides. So you can use this block to detect walls. We also have the distance sensing. So it utilizes the distance sensor in front of the VR robot. So again, here we have a hexagonal space and a circular block. Next, we have the eye sensing. So the front-facing sensor, this one. So for the eye sensing, again, the front-facing eye sensor also acts like a distance sensor and returns the distance of a detected object in millimeters and inches. So again, this is similar to our distance sensor in the VexIQ robot. For the location sensing, so it reports the X or Y coordinate position of the robot. If you can see in our playground, in our live dashboard, we have there the location. We have the X and Y. Since the robot is at the center, we are placed 0, 0 for the X and Y. Okay. Next, we have operators. So here for the operators, so this section gives the programmer the flexibility to program the robot. We have here the mathematical operators. We also have here the pick random from 1 to 10, greater than, less than to check the inequalities. We also have here the and, or, and the not logical operators for this one. This uses hexagonal space, and inside of that you can drag any hexagonal block. We also have here the round, the ABS off, or basically if you try this one, we have here the ABS floor, ceiling. I'm going to zoom this one out. If we try to click help and click this one, you can see there we have the ABS. It means absolute value. Floor for rounds down to the nearest integer. We have the ceiling, square root. We have sine, cosine. Okay. So again, for this one, operators, it utilizes hexagonal spaces and circular spaces. Next, we have the variable. So for the variable, variables are places to store values such as sensor readings for later use or for use in calculations. So much like in the robot C, there are 3 steps involved in using variables. First, you introduce where you create or declare the variable. So here we have make variable. I'm going to put this one here, forward move, submit, and then here you will see there forward move variable. Next, you can also give or assign the variable a value, and then next you can use the variable to access the stored value. So this is very similar to our VexIQ robot or the robot C. So here you can also use set forward move to there. So that is our variable name. We also have the my variable, because here we also have one. You can rename or you can delete. Okay. Next we have the my blocks. So my blocks are used to create a sequence of blocks that can be used multiple times throughout the project. So this is like a function in robot C. So I believe most of you have done this one already. This is a function in robot C. So if you want to learn more on this one, you can always click help. That's one. So if I'm going to click make block, you can input number, a boolean, or add a label there. Okay. Or we can rename this one forward movement. There. We have there define forward movement. Then for example, if we put drive forward, then we have the control, the wait for 1 second, and then we have here stop driving. If we want to use this one, you need to go to my blocks and use the my forward movement under the my blocks, this one. For the define forward movement, this will not make the robot move itself. All the commands under the when started is all the robot will do. So that's why the define forward movement is not connected to our when started branch. So if we want to play this one, and let's use the grid map. There. it moved forward, or basically it runs the program, the programs or command blocks under the forward movement. That's one. Okay, so this is very useful if you're going to create a set of commands that will be run multiple times. So instead of putting drive, wait, and stop driving multiple times under the when started, you can create a defined block and then put it there. Okay. Then lastly, we have the comments. This one. So comments are used to describe your code to help you and your teammates understand the program better. So these are texts that are part of your program that will not be sent to the robot when you download. Again, this is part of your program, but it will not be sent to the robot when you download this program. So just our practice. In every comment that you make, please make sure that your commands or your set of commands are defined or explained thoroughly here in the commands or comments, I mean. Okay, so here I will type the robot will move forward for 1 second and will come to a complete stop. Okay, again, when you're creating your programs, please utilize the use of comments. Okay, are there any questions? No questions, students? So for the further videos, you can click subscribe and ring the bell button to give you updates for our future videos. We're now in the Q&A session. Okay, so a good question here raised by Piang Piang. Is there a way po na mag-collaborate or strictly individual lang po yung paggawa ng program? So I've consulted Miss Laika with this one, and she said that our final activity for this one is strictly individual. Okay, so since this is web-based, you cannot collaboratively do it with our with the other students. So for the final activity, so I believe Miss Laika have already discussed it with you that your final exam is also your final activity. So Miss Laika will post uh, the mechanics of your final activity in your Schoology account. Are there any questions? So I think there are no more questions. If you have further questions, you can always uh, chat with Miss Laika, or in any way you can communicate with her. So that's it for our navigation of Vexcode VR. Thank you for joining me in this webinar hosted by First EduSpec Inc. for the Ust-Angelicum Senior High School learners. Thank you. And again, please hit that subscribe button and ring the bell icon to give you updates on our future videos. Thank you.